Well, hi everyone. We are working on practice test 10, and you're going just to set up the test. If you look at it, we're going to have converting quadratic equations to vertex form. I got two of those and asking for the vertex, the axis of symmetry, and how it opens. There is 1, 2, where you have to graph the quadratic inequalities. There's one problem where I'm having you solve a inequality, a quadratic inequality with graphing. And then there's a 2 where I'm asking you to solve quadratic inequalities algebraically. So that's kind of the format of the practice test, and that's going to be the format of your test too. Alright, so number 1, convert the quadratic equation f of x equals x squared minus 10x plus 3 to vertex form. Remember, vertex form is y equals a times x minus h squared plus k, and that we're going to have to complete the square. That's the skill that's involved in getting this accomplished. Alright, and then give all that information. Equation of the axis of symmetry, the vertex, and how it opens, up or down. Alright, so I'm going to make it y. I have f of x here. I'm going to make that y equals x squared minus 10x plus 3. And I'm going to group the x squared minus 10x together plus blank, put a plus 3 out here, and then whatever I added I'm going to subtract here so I don't change the problem. And then the b over 2 squared is necessary, and that's negative 10 over 2 squared, which is negative 5 squared, which is 25. So I'll put a 25 here and a 25 here. And I got y equals x minus 5 squared. This number goes with the x. This is equal to this, so we're not changing anything. 3 minus 25 is negative 22. And once we're here, we name the vertex at 5, negative 22. The axis of symmetry is x equals 5. And this one, positive coefficient, means it opens up. Number 2, it's the same instructions. Convert to vertex form. So what I'm going to do first, though, on a problem like this, when there's a coefficient other than 1 of x squared, I'm going to factor it out of this, and I'm going to divide this out too. And then put the plus blank, and then have the plus 17s out here still. And then I'm going to subtract 3 times that blank. I have 3 times this. I want to undo it, so I'll subtract 3 times that. Well, let's figure out what b over 2 squared is. That is negative 12 over 2 squared, which is negative 6 squared, which is 36. So we'll put 36 here, put 36 here. Alright. That's my first mistake of the video, but I caught it before I... Okay, now it's time to back up. This is what I'm taking. Not this. It's this. That is the b value I'm using after you factor, which is negative 2 squared, which is 4. Let's put 4 here and 4 here. And y equals 3 times x minus 2 squared. This is 12. 17 minus 12, that's 5. So I'll put 2 here, and for the x coordinate, always go opposite, and 5 here. The axis of symmetry is x equals 2. This one also opens up. Alright, If I have a negative coefficient, it would open down. I just neglected to put one of those in the practice test. This one would open down. So, but what are we doing here? We are actually graphing a quadratic inequality. Inequality means doesn't have an equal sign, has less than or equal or greater than or equal or less than or greater than. So we're going to graph the related function with either a solid or dotted line. I just included our notes. You need to know how to fill in these blanks because the blanks will still be there when you look at the test. Test a point that is inside the parabola to see if the inequality is true or false. If the statement is true, then shade inside the parabola. If false, then shade outside the parabola. I think they're just like the notes you got. Now, the related function is y equals negative x squared plus 3x minus 5. Now we're going to make a good graph of this, and I'm going to figure out what negative b over 2a is. That's something else you should know. Negative b over 2a, that's negative 3 over 2 times negative 1, which is negative 3 divided by negative 2, which is positive 1.5. And I'll put 1 here, I'll put 0 here, I'll go 2, I'll go 3. I'm going to make this graph. 0, I do know is going to be negative 5. I calculate, but now when I do 1, this is negative 1. 1 squared is 1, make it negative, plus 3 minus 5. Negative 1, 3, that's 2 minus 5, that's negative 3. Now 1.5, I'm going to use the calculator for that one. And negative 2.75. Pretty sure this is going to be negative 3, and this is going to be negative 5. Okay, so 0, negative 5, 2, 3, 4, 5 is here. Negative 1, negative 3. 1.5 negative 2.75 is 1.5 is like right around there, 3/4 of the way between these two blocks. That's really close to negative 3 and 3 negative 5. So didn't look, but this one we're going to use a solid line, right? Okay. Now, test point. For my test point, I think I will use, let's go 1, 2, 3, 4, 5. I'm going to use 1, 5. Any point, any ordered pair inside here would be good to use. And I'm going to test it, and y is less than or equal to negative x squared plus 3x minus 5, our original function here. And y is 5. Is that less than or equal to negative 1 squared plus 3 times 1 minus 5? when I plugged 1 in before, I got -3. Is 5 less than or equal to oh, shoot. That's not 1, 5. That's 1, -5. Oops. Okay. This is -3. Is -5 less than or equal to -3? The answer is true. Yes, it is. And if it's true, and I test it inside the parabola with a point, then I'm going to shade inside the parabola. So this one requires shading. Okay. This one. Okay. I've already filled out the same thing up here, so I'm not going to go through that again. But y equals 3x squared plus 6x minus 4 is the related function. Let's see if I remember to do this when it's time to draw it. But it's a dotted line. This one's going to be a dotted with this. There's no line under it. If the line's under it, it's solid. If the line is not under it, it's dotted. Okay. So y equals 3x squared plus 6x minus 4. Let's figure out what negative b over 2a is on this one. Negative b, that's -6 over 2 times 3. -6 over 6 is -1. Okay, that is where our axis of symmetry would be. That's what the vertex, the x-coordinate of the vertex would be also. So let me go -1, -2, -3. Let's go 0 here, 1 here. And I have 3 times -3 squared plus 6 times -3 minus 4. That's 9 times 3 is 27 minus 18 minus 4. That's 9 minus 4 is 5. Let's see, 3 times -2 squared plus 6 times -2 minus 4. That's 4. That's 12 minus 12 minus 4. That's 0 minus 4 is -4. Okay, we got 3 times -1 squared plus 6 times -1 minus 4. Should get our vertex here. That's 3 minus 6 minus 4. -3 minus 4 is -7. I do believe that this will be -4, and it is 0, so yeah, that will be, and that's 5. Alright, so let's plot and look at what we got here with a dotted line. -3, 1, 2, 3, 4, 5 is here. -2, -1, 2, 3, 4 is here. -1, -5, 6, -7 is here. 0, 4 is here. 0, -4 is here. 1, 5 is here. Okay, my dotted line for the related function there. That's all dotted. Now, test point. I think I will test this point right here. That point is -1, 0. And I'm testing it in our original graph. Y is 0, our original function. It's not even a function, our original inequality. 3 times -1 squared plus 6 times -1 minus 4. Oh look, I've done that already. That is -7. Is 0 less than -7? 0 is not less than any negative. 0 is bigger than all the negatives. So this is false. So I am going to shade not the inside of the parabola, I'm going to shade the outside of the parabola. Oops. Alright, this point is false. Every point in here is false. Means every point out here is true. Okay, number 5. We're going to solve this one by graphing. Got steps here. Graph the related function. So we're going to graph y equals x squared plus 6x plus 8, making sure we get the zeros on here. Well, let's x equals, and this will be dotted. Well, that doesn't matter. That doesn't matter. X equals negative b, or negative 6 over 2a, 2 times 1, which is negative 3. X equals negative 3. Alright. Negative 2, negative 1, negative 4, negative 5, x, y, negative 1 squared plus 6 times negative 1 plus 8. That's 1 minus 6, negative 5 plus 8 is 3. Negative 2 squared plus 6 times negative 2 plus 8. That's 4. 4 minus 12 is negative 8. Negative 8 plus 8 is, okay, that's a good sign, isn't it? 0 is in our table. We don't have to look for it. Negative 3 squared plus 6 times negative 3 plus 8. That's 9 minus 18 is negative 9 plus 8 is negative 1. I'm going to put a 0. Oh, another 0 and a 3 here. So let's plot. Negative 1, 1, 2, 3. Negative 2, 0. Negative 3, negative 1. Negative 4, 0. And negative 5, 3, not negative 3, negative 5, 3. Alright, so I'm drawing this. Now, it's just greater than, so we're looking, I'm going to put open circles here at the x-intercepts. This is greater. I should have filled this in. Look to see which part of the graph is above the x-axis for greater than and greater than or equal to. Look to see which part of the graph is below the x-axis for less than or equal to. Alright, looking to see, it's greater than, so we're looking at what is above. What's above? This tail is above the x-axis, and this tail of the parabola is above the x-axis. Alright, they're going away from each other. So this are the solution parts. This is an OR, and this is x is less than negative 4, or x is greater than negative 2. Okay, that's the one that we would solve by graphing. Now we're going to solve algebraically this inequality. We find the zeros, we put them on a number line, we get a test point in each interval, and we give the solution set. Look at that. So let's find the zeros. This is already set up. You got to have it set at 0 on one side. So I'm going to use the quadratic formula. It's right here. A is 1, B is negative 4, C is negative 12. So double negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 12 over 2 times 1. And that equals 4 plus or minus the square root. Okay, let's take the negative 4 and square it. That's a negative 12 here, by the way. Okay. Minus 4 times 1 times negative 12. Wait for it to focus here. There we go. That is 64. That's a good number, isn't it? It's a perfect square. You take the square root of 64, you're going to get 8. If you don't believe me, there. Alright, so that's 4 plus or minus 8 over 2. And 4 plus 8 over 2 is 12 over 2, which is 6. And 4 minus 8 over 2 is negative 4 over 2, which is negative 2. So we found the zeros. We're going to put them on a number line. Negative 2 is on the left, 6 is on the right. I'm going to put in closed circles. And I'm going to test something over here. Let me test negative 3 in our inequality. Negative 3 squared minus 4 times negative 3 minus 12 is greater than or equal to 0. This is 9. Plus 12 minus 12 is greater than or equal to 0. This is 0. 9 and 0 make 9 is greater than or equal to 0. This is true. Alright, I'm going to try 0, and I have 0 squared minus 4 times 0 minus 12 is greater than or equal to 0. This is 0, this is negative 12 is greater than or equal to 0. This is false. So this gap does not get filled in. Then we do the 6. 6 squared minus 4 times 6. Nope, don't do the 6. I'm going to do 7. Okay, 6 is a 0. I don't want a 0. I want something right of 6 to see what it does in here. Okay, 7 squared. That's what I'm going to test is 7. 7 squared minus 4 times 7 minus 12 is greater than or equal to 0. And that's 49 minus 28 minus 12 is greater than or equal to 0. 49 minus 28 is 21. 21 minus 12 is 9. 9 is greater than or equal to 0. That is true. So I'm going to shade there. This is an OR. This is an OR, so we are going to say x is less than negative 2 or x is greater than 6 or equal to. Or equal to. If this is or equal to, so are these. Okay, there's that one. Got one more. Okay, we're going to solve this one algebraically. And to do that, we have the same steps. Okay. X equals negative b plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a times c, which is negative 3, over 2 times a, 2 times 3. So that is 2 plus or minus the square root. This is, I'll do it in the calculator. negative 2 squared minus 4 times 3 times negative 3 is 40. Alright, that's not a perfect square. Over 6. And the square root of 40 is, I'm going to use 6.3. I'm going to round to the nearest tenth. 2 plus or minus 6.3 over 6. So we got to do 2 plus 6.3 over 6 and 2 minus 6.3 over 6. And that is 8.3 over 6. That's negative 4.3 over 6. Alright, 8.3 divided by 6 is 1.4. Negative 4.3 divided by 6 is negative 0.7. So I'm ready to put them on the number line now. Negative 0.7 here, 1.4 here. I'm going to test negative 1 in this inequality. So 3 times negative 1 squared minus 2 times negative 1 minus 3 is less than 0. So that's 3 times 1, which is 3, negative 2 times negative 1 plus 2 minus 3 is less than 0. That's 0. So is 2 less than 0? Answer is no. It is not. Okay, so this is false. We would not shade there. Let's put 0 in and go 3 times 0 squared minus 2 times 0 minus 3 is less than 0. So this is 0 minus 0 minus 3. So negative 3 is less than 0. Okay, I'm going to put open circles here and here and shade because 0 was true. I'm going to guess bigger than 1.4 is not true, but I'll try 2 just to make sure. 3 times 2 squared minus 2 times 2 minus 3 is less than 0. That's 12. Minus 4 minus 3 is less than 0. 8 minus 3 is 5 is less than 0. That is false. Okay, this is an and. My final answer is right there. All right, guys, you take care.